Emostel.
Alright, so welcome to this video, and then in this video we are just going to be talking about the cross products of vectors in another kind of dimension. Still the same process anyway, but a new observation. Follow me. Alright, so in this case we drew like the normal three-dimensional plane. See, don't be scared about the diagram, there's nothing there. Okay, it's just I just drew the normal three-dimensional plane that we usually draw. Okay, where this one is the x-axis, this is the y-axis, this is the z-axis. That's just what I did here. Finish. And then what I did here is just I tried to rotate. I told you before that even all these axes that we are dealing with, I told you in the first or second video in this series that even these axes, they themselves, they are vectors. Why? They have magnitude and they also have what? Direction. Those they themselves are vectors. So whatever you do to vectors also applies to them. All right. So now, as you have it this way, if you cross the same way you can cross two vectors to produce another vector, a new vector. So we discovered that the more you cross x over y, then if you cross x over y, it will produce z, because that would be like an upward movement like that. Okay. So therefore, we are now going to be considering it. We are not going to be using x, y, z. We are going to be using their unit vectors. Okay. You know, the unit vector across the x-axis is I. The unit vector across the y-axis is j. And the unit vector across the z-axis is k. Now, this diagram is beginning to make sense to you, right? Good. Mathematics is not scary. But when you see the diagram, you want to run away. But it's very simple. You only need someone to break it down to you. Okay. Now, you have it this way. These arrows are just showing the way I decide to cross them over. So I'm crossing x over y to produce z. If you cross z over x, it will produce y. You understand? And if you cross x over y, it will produce z. And then the process just keeps going. Then all of these ones I wrote in dots shows us the opposite direction of the crossing. Meanwhile, if this is the positive y-axis, then I decide to make the negative y-axis to be like this, so that it should just show that it is the negative y-axis. All right. This one too here now is a negative z-axis, while this one here is the negative x-axis. Simple. You see that? Then and now all of these things that you are seeing is the direction of the crossing. You see that it's very simple. No issues. So now, what are we going to get from this when we decide to cross them? It is noticed that if you cross the unit vector I, you cross it over j, you are going to get what? K. You are going to get k. All right. So in a similar manner, if you cross y over z now, you are going to get j cross what? J cross k. It will produce the vector x, which is I. All right. And then if you also cross z over x, which means k is crossing I, then you are going to it's going to produce vector j. All right. So that is how we see it. Then if you decide to do it the other way around, in each case, remember that when you turn it the other way around, it's going to produce a negative result. So which means that if you do I, if you do j cross k cross I, you are going to get negative k. If you decide to do k cross j, you're going to get negative I. And if you decide to do I cross k, you get the negative j. All right. You see that? So that's how it goes. Now, but in the other way, if you decide to say, okay, maybe just I cross I, the answer is going to be 0. You know why? So we will assume that we are having two parallel vectors, because vector I crossing vector I itself. So it's going to be assumed that they are parallel. And remember what we told you earlier, that when two vectors are parallel to each other, no angles are formed between them. It means that the angle theta is 0 and sine 0 is 0. So 0 multiplies everything and kills it. So which means that the result we get here is going to be 0 when two same vectors cross each other. So the same thing is going to happen here. Equal vectors, j crossing j gives 0, and k crossing k also gives us 0. I believe you understand the scope. So we want to apply that knowledge to solve this question that we have here. All right. So the question says minus 6i crossing 2j. So just do minus 6 times. So it's just going to be like minus 6 times 2 first. Times 2 first. Then multiply by I cross j. So, all right. So minus 6 times 2 will give you minus 12. Multiply by I crossing j. When you look at the table, if I cross j, we have a positive k. So the answer is minus k. All right. So here too, we have minus 4 cross 1. Minus 4 times 1, because this is minus 4. There's an invisible 1 here. And then you multiply it by I, okay, I crossing k. And if you look at our table, when I crosses k, what happens? I cross k to give us what? Minus j. Minus j, right? So the answer here is minus 4 times 1 will give you minus 4. Then multiply by what? I crossing k, that's what? Minus j. So minus times minus is what? Is plus. Then 4 times j is 4j. You get that? So the answer here is 4j. Now if you look at this, okay, 3k times 3i. So just get the 3 times 3, okay, then k times I. And if you check our table, k crossing I will give you j. So 3 times 3 is 9. K crossing I gives you j. So the answer is 9j. Then if you check this one out, we have 4 times 2, that's 4 times 2, okay? Then k crossing I. So if k crosses I, you have j. So 2 times 4 is 8, so the answer is 8j. You get that? And then if you check this one out, 2j and 0, okay? Expectedly, everything it will be 0. I don't know why I did this anyway. Okay, so everything is going to be 0. Just no need for anything here. Okay, but let's say we change it to something like 2j cross I. Let's just leave it this way, 2j cross I. So 2j cross I will be 2 times 1, all right? Then j cross I. So 2 times 1 is 2. Let me extend the answer here. 2 times 1 is 2. Then j cross I from the table is minus k. So at the end of the day, we have what? Minus 2k. Because positive 2 plus times minus is minus, 2 times k is k. And then that is how it goes. All right, you see that? Very fast, very sharp, very easy. So anytime you come across a question like this, you know exactly what to do. There's no need to cram. Just understand the process. Get out the stuff, put the two, do the number operation between the numbers, then then get the result for the unit vectors, and then you are good to go. So see you in the next video. In the next video, yeah, we're going to be talking about the direction cosine. All right, see you there. Bye.